We'll start our tour with the planet that's closest to the Sun, Mercury. Mercury is the first of the 4 terrestrial planets. The others are Venus, Earth, and Mars. The word terrestrial comes from terra, the Latin name for Earth. Unlike the large gas planets, Earth is mostly rock. Since Mercury, Venus, and Mars are also rocky, we call them the terrestrial planets. Mercury is tiny. It's a little bigger than our moon, but smaller than some of the other moons in our solar system. It's also a planet of extremes. Since it's so close to the Sun, the temperatures on Mercury can reach about 800 degrees Fahrenheit, more than enough to melt lead. On the dark side, temperatures can plunge to 200 degrees below zero. Mercury's surface resembles our moon. It's heavily cratered, as you can see here. Most of what we know about Mercury comes from the Mariner 10 space probe, which flew by Mercury in 1974 and 1975. We don't yet have pictures for all of Mercury's surface. In this mosaic, the white stripe on the top is a blank spot where we don't have photographs. It isn't actually on Mercury itself. Mercury causes serious problems for evolutionary theories. First of all, we've learned that Mercury is very dense. So dense, in fact, that most scientists believe it has an iron core occupying over 40% of its volume. We don't know for sure that this exact core structure is there, but we do know how dense the planet is. We know this because we've measured Mercury's gravitational pull on our spacecraft. There's a lot of material packed into a small amount of space. This causes a huge problem for evolution. Evolutionary models say Mercury can't be this dense, not even close. Here's how one evolutionist astronomer explains it. The driving force behind previous attempts to account for Mercury has been to fit the high density of the planet into some preferred overall solar system scheme. It has become clear that none of these proposed models work, and the high density is conveniently accommodated by the large impact hypothesis, which makes Mercury unique. Okay, so this problem is solved by the large impact hypothesis. What is that exactly? Well, evolutionists believe that Mercury did actually form in the way evolution predicts. But then, this happened. Do you remember all those asteroids that were supposedly flying around in our early solar system, turning into planets? Well, after Mercury formed in the correct way, the way that evolution expects, one of those asteroids crashed into Mercury and stripped away all the lighter material from it. The lighter stuff just went away into space somewhere, leaving behind the dense material that we see in the planet today. But where's the proof for this event? Only that if it didn't happen, Mercury would disprove evolution. Obviously, this isn't a good standard of proof. But that's not all. Evolutionists received another rude jolt when Mariner flew by Mercury and discovered this little planet has a magnetic field. But according to evolution, it can't have a magnetic field. To understand why this is important, we need to talk about magnetic fields for a moment. There are several reasons why a planet could have a magnetic field, but most of them require the planet to be young. Since evolutionists believe that the planets are all billions of years old, this means there can be only one source of magnetism for the planets, a dynamo deep inside each planet. A dynamo means there is hot, liquid metal moving around inside each planet. As it flows, an electrical current is produced, which creates a magnetic field. This is a complicated process, so I won't bore you with details. The important thing for now is this. In order for a planet to still have a magnetic field after billions of years, it has to have a liquid core. But, as one evolutionist has pointed out, Mercury is so small that the general opinion is that the planet should have frozen solid eons ago. Therefore, according to evolution, Mercury can't have a liquid core, so it can't have a magnetic field. But it does have a magnetic field. How do evolutionists deal with this problem? One popular idea is that Mercury doesn't have a pure iron core. Instead, it has some sulfur mixed into the iron. This would prevent it from freezing and allow Mercury to have a magnetic field today. But this creates a much bigger problem for evolution. The nebula theory says that volatile elements like sulfur can't have condensed this close to the Sun. So, in trying to rescue Mercury for the evolutionary theory, the entire theory itself is being undermined. So here's what you aren't being told about Mercury. Evolution says it can't be dense, but it is. Evolution says it can't have a magnetic field, but it does. And trying to rescue evolution from the facts is just making the problem worse. Mercury is a tiny planet, but it causes huge problems for evolution. As it says in 1 Corinthians 1:27, God has chosen the foolish things of the world to confound the wise, and God has chosen the weak things of the world to confound the things which are mighty.